Hello, Algebros. Today we are going to talk about simplifying radicals, adding, subtracting radicals, and multiplying radicals. It's going to be broken down into 3 parts, and hopefully this first part is review for you. You've seen simplifying radicals at some point in your math career, so hopefully this first part is fairly simple. We are going to talk very briefly about the parts of a radical. So when you see a number written out here like this is a coefficient. This little number is the index. The number underneath is called the radicand. And then this is just simply the radical symbol. For index numbers, it is good to note that for square roots, there is no index number written because it is understood. It's kind of like not writing a 1 in front of a variable. It's understood that that's what that is. I should say if. If the index is not shown, it's understood to be 2. All right, so let's go ahead and get started. Okay, so simplifying radicals, we want to see what we have underneath the radical that we can take out. So, in a quick example that we would understand, if we had the square root of 36, we should know right off the bat that 36 is a perfect square, and so the square root of 36 would equal 6. Now, diving a little bit deeper into that, if we were to factor 36, it could factor into 6 times 6, which is why the square root of 36 is 6. But we're going to go through today, and we're going to go through a process called prime factorization. So we're going to get down to the prime numbers that these values factor into. And the reason we're going to do that is because we're going to deal with a lot of numbers that are not perfect squares. So understanding why we are going to a prime factorization shows us on a deeper level what is happening. So the prime factorization of 36 would be 3 would work, but 2 times 18, 2 times 9, and then 3 times 3. So since we are under a square root, that index is understood to be 2, we are looking for pairs of numbers. Pairs of numbers would indicate that it is a perfect square. So I have a pair of 2s and a pair of 3s. So what this really is saying is that the square root of 36 equals 2 times 3, which is 6. Now we don't show all those steps for numbers that we already know because it's understood and we're to a point where, okay, I know the square root of 36 is 6, but I wanted to show you an example that you would understand and show it to you in all the steps that we are going to be using in these more complex examples. So number 1, we're going to take 180 and we're going to factor it down to its prime factors. If a number is even, I always start with 2, just because we know it's going to go in there. If it ends in 0 or 5, you can start with 5. It doesn't really matter. So 2 times what would equal 180? Well, I just take 180 divided by 2. So 2 goes into 18 9 times and then 0. It's still even, so I'm going to continue to go by 2 until I can't. 2 goes into 9 4 times with 1 left over. 2 goes into 10 5 times. So now it's no longer even. I'm going to go ahead and I typically move up the line with the numbers I use. So I go 2 to 3 to 5. But since it ends in 5, I'm just going to jump to 5. So 5 times 9, and then 9 factors into 3 times 3. And then we can't factor any further. This is the prime factorization. So again, we're underneath a square root. So you notice that there's no index number written here. So it's understood to be 2. So if we're under a root of 2, we're looking for pairs of numbers, or 2 of a kind. So I have 2 2s, and I have 2 3s, and I don't have another 5, so 5 has to stay underneath the radical. I also can expand my x to the 4th out into x times x times x times x. That's the prime factorization of x to the 4th power. I have a pair of x's and another pair of x's. So this pair of 2's will come out of the radical as 2, and this pair of 3's will come out of the radical as 3. This pair of x's will come out as x, and this pair of x's will come out as x. So what that looks like at our next step is 2 times 3 times x square root of the 5 that is left over. There were no variables left over. So now to simplify that further, 2 times 3 is 6, x times x is x squared, radical 5. That would be our final answer. Now, you certainly do not have to show all those steps, but I'm showing every single step so that way you see what is happening. All right, so let's take a look at number 2. We have the cubed root of 256 times n to the 5th power. Now we're underneath a cubed root, so we're going to be looking for 3 of a kind in order for it to come out of the radical. Because 3 of a kind would be a perfect cube. So we need to factor 256. It is even, so I'm going to start with 2. 2 goes into 2 once, 2 goes into 5 2 times with 1 left over, 2 goes into 16 8 times. It's still even. 2 goes into 12 6 times, 2 goes into 8 4 times. Maybe if you want to use bigger numbers to start factoring, you can. It's even, so I'm going to continue to go by 2's. 2 goes into 6 3 times, and 2 goes into 4 twice. It's still even. 2 goes into 3 once, with 1 left over. 2 goes into 12 6. 2 times 8. 2 times 4, and 2 times 2. We also have n to the 5th, which would be n times n times n times n times n. So don't start circling the pairs of numbers because, again, we are underneath a cubed root. So we need to find perfect cubes. So actually, let me use a different color. So I have 3 2's, 3 2's, and I have 2 left over. So it's really important when you are prime factoring that the 182 or 128, the 64, the 32, the 16, the 8, the 4, the 2, those numbers no longer matter because they've already been factored. So you can't double use numbers. All right, and we also have 3 n's here and 2 left over. Okay, so the perfect cubes come out. So this would come out of the radical as a 2. This would come out of the radical as a 2. And this would come out as an n. But everything else that was not a perfect cube or had 3 of a kind has to stay underneath the radical as it is. So we have 2 times 2 times n coming out. Underneath the cubed root, we have a 2 times 2 left and an n times n left. So to simplify that, 2 times 2 is 4, n cubed root. 2 times 2 is 4, n times n is n squared. So this would be our final answer. All right, number 3. We are underneath a 4th root. Right, so to factor this, it's not even, it doesn't end in 5 or 0, it's not divisible by 3. Oh, actually it is divisible by 3. But the first jump we can make is 7. You could do it by 3, but 7 goes into 56 8 times, and 7 goes into 7 once. 81. 3 goes into 81. 2 with 2 left over, 21 7. 3 goes into 27 9 times, and 9 is factored into 3 times 3. We also have 6 x's and 2 y's. Okay, we are underneath a 4th root, so I need 4 of a kind in order for it to come out of the radical, and we just so happen to have 4 3's, and we do have 4 x's, and everything else has to stay underneath the radical. So remember, this comes out as a 3 and this comes out as an x, because it's the cubed root of 8, or the 4th root of 81, which would be 3. So 3 comes out, x comes out, and underneath our 4th root we still have a 7. We have 2 x's and 2 y's, and to simplify that further, 3x 4th root of 7x squared y squared. One more example to go over together. Square root of 72 x to the 4th y to the 3rd. So if we simplify 72, it is even, so let's start with 2. 2 goes into 7 3 times with 1 left over. 2 goes into 12 6. 2 goes into 3 once with 1 left over. 2 goes into 18 9 times. What? No, that was right. What's going on? 8. 2 goes into 18 9 times. I was getting ahead of myself one step. And 9 can be factored into 3 times 3. We also have x times x times x times x, and y times y times y. We are underneath a squared root. Again, remember, it's an index of 2 if it's not written. So we're looking for pairs or 2 of a kind. I have a pair of 2's, a pair of 3's, and one poor 2 that has nobody. I have a pair of x's, a second pair of x's, and I have one pair of y's, and that poor y has to stay home because he doesn't have a buddy. Alright, so this comes out as 2 times 3 times x times y, square root of 2y. So to simplify that all the way, that would be 6x squared y, square root 2y. Again, you do not have to show that step at all. The only reason I am doing it is just to show you where my numbers are coming from, instead of just saying, oh, well, we have a 2 and a 3, and so it comes out of 6. All right, so again, you don't have to show that middle step. If I was doing it on my own paper, I would not be showing that middle step because I understand what's going on. All right, stay tuned for the next 2 videos on adding, subtracting, and multiplying. All right, have a great day and happy mathing.